Hello guys, my name is Diego Pacheco and this is another Java video. Today, I actually want to talk about a pattern, and this pattern not necessarily need to be coded in Java. We can code in any language like Go, like Rust, Clojure, Scala, Zig, whatever language. So basically today I want to talk about a pattern called Tolerant Reader. So I have an IntelliJ IDEA Java project here, and I'm gonna open it. And this pattern is really powerful, especially if you need to, let's say, implement a service and you need to be backward compatible with different versions of a module. And that module could be like a persistency entity, or it could be a domain event from Kafka or anything like that. So actually, in this video, what I'm gonna show, it's an implementation using a specific serializer, right? I'm using like standard serialization, but actually it could be anything. You could be using Jackson, you could be using JSON, it could be protobuf, it could be binary, any other binary format, CSV, whatever form of serialization and deserialization you want to use, the pattern will be the same. So let's take a look on the pattern and understand how it works, right? So imagine like this. I have a person object, right? And I am explicitly naming this as person view 1. Sometimes they name, people like to name models or objects or DTOs or entities on the package level, right? So the package has like v1 or v2, that's also fine. But here, for simplicity, I just name the object, which is also fine. I'm implementing serializable, and my person view1 just have a name and email. I have a public no arguments constructor. I have a full constructor with name and email. I have getters and setters, equals, hash code, and toString, right? So let's say now that I am serializing and deserializing this object, and then there's a business change. And now I got person v2. So if we look person v1, right, we have name and email. In person v2, what we have, we are adding two other fields, which is an ID, which is a UUID, and we have the sex being a string. And person v2 extends person v1, right? So we don't need to be implementing getters or setters and everything. And then we just add constructor, full constructor now with the 4 fields we have, getters and setters for ID and sex, and equals hash code and toString. Now, how we make the reader tolerant, right? Which is the name of the pattern. So here, let's say I have my person serializer, and here I'm serializing using Java object serialization, which is like not popular and not actually a good way to do this. But honestly, like I said, it could be JSON, it could be protobuf, protostuff, whatever serializer you want to use, Avro, you name it. And so let's understand how this works. So here I have methods to write a person v1 and to write a person v2, but it has also a method to write a person v2. So in order to write, I have two different writers, but to read, I just have one reader, and this reader is smart enough to not break when there's a person v2 there. And that simulates like two different applications. Imagine there's one application reading and writing v1, there's another application writing v2, and there's another application that just reads v1, it doesn't care about v2, right? So if you introduce v2, you're gonna break v1, the apps that's reading v1. But with the tolerant reader pattern, we can avoid that app to break, so the application is more resilient, it's better for consumers, it makes tests more resilient as well, so it's definitely a good idea. So let's see the implementation. So write v1, I create a hash map, and in this hash map, I basically have a property for the name and for the email, and I get the name and email from the person. Then what I do a file output stream, and then I create an object output stream, and what I write down is the map. So as you can see, I'm not writing down the person directly, I'm writing down a map, because this gives me much more flexibility. All right, so that's right person v1. For right person v2 is exactly the same idea. So we receive a person by parameter and the name, exactly the same parameters as the v1 method. And here we are adding all the fields, right? So we got here name and email from person v1, but we use person v2 object, and sex and ID, which is specifically to person v2. And then again we write the map. Now the reader is interesting. So when we read, we're gonna read a map, right? So as you can see here, my read object is casting to a map. And because we're casting to a map, then I'm gonna construct the person object using the map and doing gets on the map. And as you can see here, I'm explicitly just getting name and email. I'm not doing gets for ID and sex. In that way, this will always work. And I could have person v3, v4, as long as name and email are present, this will always work. So I can add the new fields and it's gonna be tolerant. And that happens because we are not explicitly binding things directly to objects. So we have this layer of indirection. Now, we saw the pattern. Let's run and see the pattern in action, right? So here I created a person v1. I call John Doe and doe@john.com. And then I write that person v1 in this file. And then I create, I'm reading that person v1 and showing that, right? So that's all about v1. Here, create a person v2, which is John Doe, John Doe, and John Doe. It's the same name in email, John Doe, in both cases, and but now we have a sex, which is his male, and we have a UID, so we create a random UID. Then I use the serializer for person v2, so I'm explicitly writing person v2 in a different file, right? And now I want to read, but as you can see as the reader, I'm reading v1, but I'm reading v1 from v2, right? So on the file, we're gonna have name, email, ID, and sex. And you're gonna see that this works, right? So let me run. Let's just wait 1 sec. Building and running right now. Yes, there we go. And here we can see, all right? So that's a very interesting pattern. Is really useful, not only for microservices, but for CQRS and event sourcing. If you're doing applications with Kafka, for instance, it's a really good pattern. If you're doing SOA for backward compatibility, is also good. If you need to, for unfortunate reasons, you need to have a distributed monolith and you need to access the same shared database, that's also an interesting pattern, interesting way to write your serializers and deserializers. So that's it for today. I hope you guys like it. See you next time. Take care. Cheers.